Throughout the semester, you're going to be completing some labs that will require you to know some osteology, some basic terminology, and some basic features of the skull and of the postcranial skeleton. A lot of these terms you might not hear again until later in the semester when you complete some future labs. So it may be useful for you to come back to this lecture later and listen to it again. We're also going to be discussing primates next week. So to sort of introduce you to primates, we're going to look at some anatomical differences between quadruped primates, which means those that walk on four legs, like non-human primates, chimpanzees and gorillas, and some differences between those and bipedal primates, those like ourselves who walk on two legs. So what we're going to do is start with some basic terminology, and I'm just going to begin with some basic terms, some directional terms that you're going to need to know. So some basic terminology that you're going to need to know, and these terms will come back up in labs and they'll come back up in lectures, so make sure that you're familiar with them. The first being anterior. Anterior is a term that means front or forward facing. So when we're speaking of a bone, for instance, if we're speaking of the skull and I am referring to the anterior portion of the skull, we would be referring to the face, so the front portion of the skull. The next term you need to be familiar with is posterior. Posterior is the opposite of anterior. So it means behind. So when we're talking about the posterior portion of a skull, we would be talking about this portion. Or, for instance, the back of your head, that would be posterior. Superior means above or top. So again, just using this bone as an example, if I use the statement, the superior portion of the skull or the superior area of the skull, we would simply be talking about the top of the skull, or you can think of the top of your head. And then lastly, another term is inferior, which means below or under. So it's the opposite of superior. So it would be where your foramen magnum is located, where your spine is entering into your skull. To give you another example of these terms using a different bone. So here we have a hip bone that's been sort of screwed together so you can see what it looks like in anatomical position. So using this terminology, this would be anterior portion of the hip bone, right? Posterior, under, below. Posterior, behind, towards the back. Inferior is below, and superior is above. So like I said earlier, you are going to need to know some basic terminology, some features of the skull that you're really going to use more so later in the semester for some of your labs where you're looking at hominid fossils. So we're going to go over some basic features. And we'll first start with supraorbital margins. So supra means above, orbital means the orbits here. So this is an area of bone that lies directly above the eye orbits. So in hominid skulls, those that have small brains and larger faces, larger jaws, you're typically going to see this area be more robust or thicker. So to sort of give you a comparison, if we were comparing, this is Australopithecus boisei, which you'll be introduced to in a few weeks, and this is a human skull. So if you look at the supraorbital margins, we would say that humans have absent supraorbital margins. There's not much thickened area of bone above the orbits, while Australopithecus boisei has pretty robust and thick supraorbital margins. You can also see a good representation of this in the picture on your slide. Keep in mind that this is a feature that is related to your muscles of mastication. So our early ancestors had really large muscles of mastication. They were eating meat that was not cooked, or they were eating nuts and roots and tubers, really hard, gritty food. So they had larger muscles that helped them with chewing. So those larger muscles would create larger jaws, and because these are attaching to the skull to help with mastication, it's going to make these areas of bone a little bit more robust, a little bit bigger in size. All right, the next term that you need to be familiar with is the sagittal crest. So again, we're just going to use Australopithecus boisei as an example. So if you're looking at the vault or the brain case of Australopithecus boisei, a sagittal crest is just a ridge of bone that's located superiorly on the skull, and it's just sort of a raised area of bone that kind of protrudes off the superior portion of the skull. Again, this is something that's related to muscles of mastication. So let me put this in anatomical position here. So you have muscles of mastication that will connect from your lower jaw, come up through your cheekbones, your zygomatics, and attach to the side of your brain case. And so if those muscles are larger and bigger in size, they're going to need more bone to attach to. That's why you do not see in humans, in modern day Homo sapiens, there's no sagittal crest present on the skull. That's because over time, as we began cooking our food, we needed smaller muscles of mastication. Those reduced in size, so we didn't need that large portion of bone for those big muscles to attach to. So again, just another example. This is Homo habilis, a later ancestor of Australopithecus boisei, and you can see there's an absence of a sagittal crest here. But noticed that you do have a little bit of presence of supraorbital margins still there on the Homo habilis skull. Again, take a look at the pictures on your slide. On the right side of the slide is a gorilla example, and gorillas have really large muscles of mastication, so they have a really prominent sagittal crest so that they have an area of bone for those muscles of mastication to attach to. All right, post-orbital constriction. Post means behind, orbital means behind the orbits. So let me put this jaw down. So post-orbital constriction is an area of constriction located directly behind or posterior to the eye orbit. So you can see how this area is sort of pinched here, and then it opens back up again for the brain case. So again, this is an indicator of large muscles of mastication. If you have large muscles of mastication attaching to the side of your skull, you need room for them. Also, you see this trait when you have a large face and a small brain. So think of a chimpanzee. They're going to have post-orbital constriction because they typically have a large face and a small brain. To give you a comparison, so I would argue that Australopithecus boisei is showing pretty prominent post-orbital constriction. However, take a look at the human, modern Homo sapien, right? So our brain has gotten a lot larger. Our face has reduced in size, so you no longer see this restriction behind the eye orbits here. So we would say that this is a feature that is absent in Homo sapiens. All right, another term that you need to be familiar with is facial prognathism. Prognathism is when the lower portion of the face projects anteriorly forward away from the midface. So if you want to zoom in, it's as though someone has sort of grabbed the maxilla and mandible area and just pulled it directly out from the face. You can see how it's really flat here and it sort of flares out here. Again, this is something that we see with hominids that had large muscles of mastication and smaller faces. To give you a comparison, here's a modern day Homo sapien. While we do see some prognathism in modern day Homo sapiens, if we're comparing the two, a Homo sapien to an Australopithecine, we would say that prognathism is absent in a human. I'll just give you one more example. This again is Homo habilis. You can see just a little bit of facial prognathism here. Smaller individual, not so robust as Australopithecines. So as time goes on and the face begins to get smaller and the skull and the brain begins to get a little bit larger, this facial prognathism will start to reduce. Again, you can take a look at your slides and notice that there are three different modern day Homo sapiens present on this slide of different ancestries, and you can see the human variation there in facial prognathism. Some humans portray a little bit more facial prognathism than others. And here's another example of facial prognathism on the chimpanzee. So you can see how it just looks like someone took the face and completely pulled it out from the mid-face, from the skull vault. All right, another term that you will need to be familiar with is the foramen magnum. So foramen means hole, magnum means large. So literally this means large hole. So this is the hole that is located on the inferior portion of your skull. And this is where your spine is going to come into your skull and meet your brain. The reason that you need to be familiar with this trait is because you're going to compare it in non-human primates and hominids. And what I want you to notice later in the semester is that in modern day Homo sapiens, those of us that walk quadrupedally that walk bipedally on two legs, the foramen magnum is located more inferiorly, directly under our skull. That's because our spine lines up with our legs. In species that walked quadrupedally and or weren't as efficient as ourselves, you're going to see that foramen magnum sort of be located more posteriorly on the skull. And that's because if you think about a quadruped walking, right, their spine directly comes out from the posterior portion of their skull. So that foramen magnum will be more posterior in species that walk quadrupedally. Good example on your slide, you can see a Homo sapien compared to a chimpanzee. You can notice the difference in where the foramen magnum is located. All right, so now that we've covered some of the features that you need to know on the skull, I just want to give you some basics about postcranial anatomy or postcranial osteology. So post is below the cranium. So any bones we're talking about postcranially is below the skull. Some key features that you need to know are mainly the bones that make up the upper limbs, your arms. Mainly, I'm going to make you focus on the humerus, and I'll introduce you to that bone in just a minute. Then we'll look at your hip and your sacrum in more detail, and I'll introduce you to some osteology of the hip and the sacrum. And then we'll cover some of your lower limb bones or your leg bones, that being the femur, the tibia, and the fibula. All right, so let's start with your upper limb bones. So you can see in your slide here, your upper limb is made up of three major bones. Most superior is your humerus, and then you have two bones that make up your lower arm, your ulna and your radius. Something that you may see again in lecture and later in the semester when we start talking about anatomical changes from a quadruped species to a biped species is the humerus. So make sure that you know where the humerus is located in your upper limb and what it looks like so that you'll be able to recognize it. Something that we'll see change and we'll talk about is the actual joint of your humerus. Obviously, this is going to change when we're no longer using our arms for in the trees for movement or things like that, or walking on them. All right, you have three bones that make up your lower limbs or your legs. The first bone and the major bone that you need to be familiar with is the femur. And then below the femur in your lower portion of your leg, you have a fibula and a tibia. So you can see that on your slides in your PowerPoint. The reason you need to be familiar with the femur is because we're going to talk about some shape changes, again, that take place at the joint throughout time as we make that transition from quadruped species to a biped species. So this is going to be something that's going to change shape. So you'll see this as we discuss Australopithecines in particular, which were our first hominid ancestors to really walk bipedally. All right, the hip, or another term for this, the os coxa, is another bone that we're going to continue to discuss throughout the semester. You're going to see this bone change throughout evolution, again, in the big change between a quadruped species and a biped species. So there's just a few features of this bone that I want you to be familiar with that we're going to keep talking about throughout the semester. The first being the iliac crest. So this is sort of this blade area of your hip. Oftentimes if you feel your hip bones on the lateral portion of your hip bones, you can feel these sort of blades. So keep in mind that these are the iliac crests. This is something that you're going to see change shape, and we'll talk about this in just a few minutes, between a quadruped and a biped species. Also, another terminology that you need to know is the pelvic inlet. And so that's basically talking about this opening here in the pelvis. So this is something that's going to change not only as we change from quadruped species to a biped species, but it's going to be something that changes as we make a transition from a small-brained species to a large-brained species. So we'll talk about Australopithecus afarensis, whose pelvic inlet was a lot smaller than a modern-day Homo sapiens. And that's because they had a cranial capacity of about 400 cc's, as opposed to a modern human who has a cranial capacity of about 1,200. So if you can think, this is a birth canal, right? So this is an area that's going to be affected by whether the species is small-brained or large-brained. All right, so that's pretty much the basics for osteology. And now what I want to do is talk about some biped versus quadruped anatomy. We really won't get into primates until next week in your next lecture, but since I'm recording here, we're going to go ahead and introduce you to some of the differences that we can see when we compare a biped species to a quadruped species. So just to remind you, a bipedal species, or a species that locomotes bipedally, is locomoting on two legs like ourselves. So an example of that is ourselves, and you're going to see throughout the semester that our hominid ancestors also walked bipedally. Quadrupedal locomotion is when the species is walking on four legs. So this would be non-human primates, anything like chimps or gorillas, and some of our early primate ancestors that we're going to talk about next week. So we'll just start with talking about the hip bone, some differences between a quadruped and a biped. So quadrupeds typically portray a really tall and flat iliac crest. So if you look at the pictures on your slide, you can see a chimpanzee on the left. And if you look at that iliac crest, it's really tall and sort of a flat blade. Compare it to the hip on the right side of the slide, a human. Humans typically portray a really round and a shorter in size iliac crest. Also, you can see when you compare those two pictures, differences in their pelvic inlet. So notice that the chimpanzee's pelvic inlet is a lot smaller than the humans. And that's because chimpanzees have a smaller brain size than human species. If you look in the middle, you will see a hip of an Australopithecus. And if you compare it to a chimpanzee and a human, you'll notice that it sort of has an in-between shape. It's not necessarily tall and flat, but it's not necessarily round and broad iliac crest either. So we're going to talk about Australopithecines later in the semester, but just to kind of introduce you now so you can see a comparison of the hip. So here's a great slide showing a comparison of a human versus a chimpanzee hip. Human on the left, chimpanzee on the right. So notice those iliac crests, right? A chimpanzee has really tall and flat iliac crest. And you can see how the human looks a little bit more bowl-shaped. So this is all indicators of locomotion. And when you think about, if you've ever been at the zoo, when you think about a chimpanzee walking bipedally, right, they can stand up on two legs and they're able to walk bipedally, but because they're anatomically made to walk quadrupedally, they sort of swing themselves to left and right when they walk bipedally. And that's because they do not have this bowl-shaped pelvis to sort of give them that left and right balance. So they're constantly balancing themselves over their hips. Another thing that we see change between a quadruped and a biped species is the shape of the spine. So quadruped species portray more of a straight or flat curve to their spine. Humans and bipeds portray an S-shaped curve, literally like the letter S. This S curve is what helps humans to stabilize our upper body over our hips as we locomote on two legs. So again, that's a lot of reason why the chimpanzee or quadrupeds that will stand up and walk bipedally, they're still kind of have this hunched over look and they can't stand straight up. And it's because they have that really flat spine that doesn't allow them direct posture directly over their pelvis. So I mentioned the foramen magnum earlier, and we talked about it a bit, but I wanted to make sure that you can see a difference between a quadruped, the location of a quadruped's foramen magnum versus the location of a biped's foramen magnum. So if you think about ourselves, where our spine is located, right, it comes directly inferior or underneath our skull. So that foramen magnum is located directly under the skull, or most inferior. If you think about a quadruped that is walking on all four legs, their spine is going to come out more towards the back of their head, or more posteriorly. So as we look through evolutionary time, that foramen magnum and its location can be really helpful for us to determine, did this species walk quadrupedally, did it walk bipedally? So keep in mind that bipeds have an inferior foramen magnum, quadrupeds have a posterior foramen magnum. So the chart on this slide is one that you're going to need to keep available to study. You are going to need to know the teeth, how many we have, and where they're located. And the reason you need to do this is because you're going to be comparing them between species later on in the semester in your labs. So as adults, we have 32 teeth total. So we have 8 incisors, which are located in the front portion of our maxilla and mandible. So you have 8 incisors, which are located here, and you can also take a look at the picture on your PowerPoint. You'll have 4 on the top, and then 4 on the mandible. You also have 4 canines, right? The pointy teeth in your mouth in the front. You have 2 in your maxilla, 2 in your mandible. Then you also have 8 premolars. And if we can get zoomed in here, I'll show you some sort of good key points. When you are trying to identify a premolar is going to have 2 cusps. So it will have 2 bumps on it, okay? So that's an easy way to identify a premolar. You have 8 premolars. You have 4 on the top and then 4 in the mandible. And then you also have 12 molars. So 12 molars will molars will typically have 3 or 5 cusps. So you can look for the bumps on the teeth to help you identify a molar versus a premolar. The reason you're going to be looking at teeth is because something I want you to notice is that as muscles of mastication change, our teeth size will change. So again, this is the jaw of Australopithecus boisei, who had really large muscles of mastication. So I want you to notice the size of these molars and the size of these premolars in comparison to the human. So this is something that you'll be comparing in different species. All right, so again, you can just notice on this slide, you can see this is a picture of an Australopithecine teeth as well. Notice that canines are a lot larger than we would see in humans, and the premolars and molars are really large. In fact, the premolars are just about the same size as the molars. All right, something else we'll be talking about throughout the semester is hands and feet when we look at a quadruped's hands versus a biped's hands. So quadrupeds, because they are using their hands for locomotion, they will typically portray really long and curvy fingers. And that's because they're using these to grasp onto the trees as they locomote in the trees. Bipeds, on the other hand, portray thick and flat fingers. So if you look on your slide, you can see a comparison between a chimpanzee's hands that look a lot leaner, a lot sort of stretched out when we compare it to a human hand. And then we also see changes in our feet when we compare a quadruped species to a biped species. So bipeds have or portray two different types of arches. And you can see an example of each of these in your slide. The first being a longitudinal arch. So a longitudinal arch runs from the posterior portion of your foot to the anterior portion, so from the heel to the toes. And this is the arch that's very important for us because it's really what gives us our spring action, sort of our forward ability to sort of push off of the ground and take a step. The other arch that we see in bipeds that we don't see in quadrupeds is the medial arch. It's labeled as the transverse arch in your slide. This one runs from the medial side of your foot to the lateral side. This arch aids in that left and right balance when we're walking. It helps us to sort of balance on our feet. So that completes this lecture, but again, this is a lecture that you're going to need to keep available throughout the semester because a lot of these features, especially those that we talked about on the skull, the supraorbital margins, the sagittal crest, those are features that you're going to be looking at in your online labs, your virtual labs. So be sure that you're familiar with those terms and you know exactly why those features are present versus why they would not be present.